You're not going to want to miss this episode of the AI Show. We talk all about Agent Framework Lab, the experimental modules of Microsoft Agent Framework. Make sure you tune in. Hello, and welcome to this episode of the AI Show. We're talking all about Agent Framework Lab. Is it lab or labs? Is it just one lab?
Lab.
He's like lab, the experimental, but it's experimental modules. Oh, you can have multiple things in a lab.
One lab, many experiments.
Oh my goodness! Of Microsoft Agent Framework, I'm here with Eric and Elijah. How you doing, my friends?
Awesome.
Another day living the dream.
So why don't you introduce yourself first? We'll start with you, Elijah, and then we'll go to you, Eric.
Awesome. Yeah, excited to be back. Seth didn't run me off after the last episode, so we're good to be back on the AI Show. Excited to be here. I'm Elijah. I'm the PM for Microsoft Agent Framework, and excited to share a little bit more on what we're doing.
Awesome. And you, Eric, what do you do, my friend?
So I'm a researcher, and I'm also a builder, and also now an architect for the Microsoft Agent Framework and previously Autogen. And so I work a lot on Agent Framework.
So now that's why he has the board flex behind him, because he's like, I'm a researcher. Oh, yeah. Like, that's why there's the
box and arrows. Boxes and
arrows. All right, so let's start first with you, Elijah. Tell us about the Agent Framework Lab. You brought some slides here.
Let's do it. So yeah, Agent Framework Lab is one of our packages within Agent Framework, where we're going to get into depth here in this episode on what exactly it does, but it's all for research, experimentation, community-driven ideas, and an open place, as it says here, for people to bring their cool creations with Agent Framework.
And this is subset of the actual Microsoft Agent Framework, correct?
Correct. And so for those who haven't checked out the original Microsoft Agent Framework episode that we did a couple weeks ago, go ahead and check that out. It was awesome. It was great to have Seth here. And for those who don't know, October 1st, we public previewed the Microsoft Agent Framework. This is the open source engine for building and orchestrating intelligent AI agents and workflows. There's a lot of great features, open standards, all kinds of stuff, and it's ready for production, ready for you guys to go build. So check out the link that's here listed on the slide to start building.
I love it. So for those that don't know, Microsoft Agent Framework is a convergence of things. Tell us about that, Elijah.
Correct. So previously at Microsoft, we had two different open source frameworks, Semantic Kernel, which came out of the product side of the house, Autogen, which Eric worked on himself. It came out of the kind of the research area of Microsoft. Both of these, Seth, were actually doing agent stuff before it was cool. And so we had a lot of great learnings from these two different things. Semantic Kernel is great for production workloads. Autogen was great for quick prototyping, and a lot of people actually were using them in production. But now we've kind of brought them together to give folks the best of both worlds and a really nice, streamlined dev experience. And so we're super excited about that.
I love it. So we have a whole episode on that. So if you want to take a look more on that, you totally can. But let's talk about the Agent Framework Lab. Eric, can you tell us about what this is and why it's important?
Yes. So first of all, I'm very happy that Microsoft Agent Framework is consolidating the Autogen and Semantic Kernel together. However, there is a kernel thought in my head, which is how do we preserve, the experimentation, the communities of Autogen that was original ethos of this project. This is why we have Agent Framework Lab, and it is designed as a place to experiment new ideas, experiments running on the cutting edge benchmarks to see how well your agent performs, as well as incubating new features for the Microsoft Agent Framework. Things like perhaps computer use, things like reinforcement learning, as well as for research. If you are doing research, cutting edge research in agents, and you want to bring your ideas to the world, to everybody, to look, try it out. This is the place to be.
So this is amazing. I love the idea of like, it's almost like you brought the enterprise side, but you also brought the research community side, and you're kind of putting them both together, with the, it's like a mullet, business in the front. Is this a bad example? I think it's a bad example.
A party. It's
Party in the back.
It's a party. It's a big party. And
I
no,
love it.
what I love about the incubation aspect of it, and to that exact bullet point, is it allows us to stay nimble and bring in all of these new research, community-driven ideas, but also still maintain kind of a stable production stuff for those who are all business, as you would say.
Yes, I love it. I am more nimble when I have a mullet, I think. I need to try that out. Just the wind going through my hair, having the community around me. I think that's exactly what we need to do. So, Eric, let's start with some of the things that are in the Agent Framework Lab. You brought this slide, and I'm curious about it. Tell us about the Gaia Benchmark and what you're doing in Agent Framework Lab to use this.
Right. So Gaia Benchmark is one of the most well-known benchmark for evaluating general purpose AI assistant. So the two words is super important. It first of all is general purpose, meaning that it's not your normal workflow agent or your single agent that are designed for a specific task. It's designed to evaluate something like what's closer to, I would say, a general purpose AI, right? So it's able to evaluate something that can look up information for you, help you to run some quick calculation, combined with writing a report on some data analysis. So it's about to evaluate agent that can do many different things and to keep track on those tasks while delivering you the actual value. So I think it's very useful as a sort of a North Star to aim for as if you're doing AI research or you're trying to build a useful chatbot that can help people with daily tasks. So this is why Gaia Benchmark I brought in here into the lab as a part of the lab module, as a built-in lab module, so that you can let's say you have an agent that you create with Microsoft Agent Framework and you want to see how well it performs, it gives you a number, right? It gives you some guidance, and it also help you to debug and see how well your agents is doing in those more realistic scenarios the benchmark provides. Yeah,
So let me ask you. So is the first sort of sub module of Agent Framework Lab? I'm trying to say it correctly. Lab is a Gaia benchmark for your agents. Is that the first module we're going to take a look at?
Yeah, that is right.
Okay, that totally makes sense. So I'm curious, how does this work? I understand you brought some code. Let's go to it, and then why don't you talk to what's going on? Is that okay?
Yeah, of course.
All right, let's do it. Here we go.
Yeah, let's show it. All right. Yeah, so here I'm showing you, the front page, and this is the installation. So you can easily install it by the Agent Framework Lab package and making sure you have a Hugging Face subscription, that part of it. And so this is very easy to use. The benchmark, the Gaia benchmark, we have have two hooks. One is, could you pause this for a sec?
Sure.
So yeah, so one of the hook is the telemetry. So it allows all the benchmark output to be exported to a standard observability panel. And the other one is the runner. The runner will automatically collect the data set from the Gaia, from the Hugging Face website, and then run the benchmark in a parallel workers. So it's going to be running very efficiently.
So let's pause right here, because if I remember right, and because I started playing with Agent Framework, I play with it in C# a little bit. This is Python. Is task an Agent Framework task?
Right. So here, the task is a pseudo implementation.
Okay.
So we will when we run the samples, we'll run the actual agent. But this is just to show that you can plug in any agent you want. And so the run task method function is just a placeholder for you to implement your own agent.
And is it what's a task? Is it just like some some function primitive or something?
Yeah, so a task is a description of the work that the agent supposed to do, as well as a set of files that the agent might need in order to do the work. For example, the task would be, I have this video, and it help me analyze the video and tell me which part of the video contains somebody wearing a yellow jacket, for example.
That makes sense.
Yeah.
So it's basically like it's everything that it's like an agent with everything it needs to do a thing, and we want to evaluate, is it doing the thing correctly?
Yeah, well, the tricky part is sometimes the task requires more data than what the file provides. So the agent
Oh,
have to browse the web, have to search through various kind of catalog, or it also needs to run some code, write some code and run it in order to really get the answer. So
in
yeah,
general, like here's a question, and I'll play in a second. Here's another. Generally, I found like when you're running a stochastic process like this, you need to do tests, but in expectation, meaning that you need to run it multiple times. Is this a single shot scoring and test and score, or is it something that you should be running a lot of times to get like some sense of like? So
yeah.
the law of
So
large numbers helps you out here.
right, I mean, the variance totally would need to take consideration. So for simplicity, like the run method here, only run it at one shot, but of course you can run it many times and it aggregates results.
I see, but the scoring happens on a single shot.
Right, that you can the score can be run on top of multiple results. So you 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 can run it on one result to see quick numbers, or you can run it multiple times and then get the aggregate.
All right, so
Aggregate
let's keep going here because I want to see
Yeah.
the rest of what was going on. So, all right, so this
Yeah.
is the thing that runs it. All right, what are we looking at here?
Yeah, now we're gonna run a sample. So we're gonna start with like inside the lab module. We don't gonna give you like a super sophisticated implementation as of it now. Maybe you can contribute one in the future. So we're gonna have some really simple single agent that can do basic things. So one of the single agent I'm using here in this example is it's just an agent that has code executor, like code interpreter, and a Bing grounding tool. So you can search your web and get the synthesized results from the Bing.
So let me pause right
So
here. I'm looking at this. It looks like you're spitting out something to an OTel collector. Is that what I'm looking at
right,
here?
yeah,
Okay.
I think this is one very special thing about this benchmark is it actually works perfectly with OTel. So
Hmm.
all the data, instead of coming on some custom format that I dreamed up with, it's going to give you the standardized Gen AI traces. So
Hmm.
you can display the result in any dashboard that support the Gen AI telemetry standard from OpenTelemetry. So
And
Awesome.
Eric, oh, sorry, Seth. I was just Eric. You mentioned that we're using the Bing grounding search. What kind of agents are we using here to evaluate?
right, we're using Azure AI agent.
Nice.
Yeah, and you can fast forward this video. So there is a right here we go. So I'm using the Aspire dashboard to taking the analyzing the telemetry of the run. And so you can see in real time the results are piped through the Aspire dashboard. So you can see, like, for example, this in this specific task, what did the agent say as a result of running the task, and then what is the message that the Gaia task runner provides. So you can see when the task is failed, that you can show it up on the dashboard, and then you can aggregate those results to get your numbers.
So
So it's
I'll just keep running. So I see. So now, so this is not just a way to measure the actual and the videos over. So it's not just a way to measure the actual score, but it's also a way to look at what actually happened at the same time if you use the OTel collector. And
right,
obviously it's going to Aspire, but it can go to like Foundry or whatever else
of
as an
course.
OTel collector.
Yeah, yeah, of course. So because it's plugged in with the standard telemetry telemetry, so you can use your favorite observability tool to debug and to evaluate your agent
Awesome.
from
And there's a
there.
second video. What's in that one? Should we play it?
Right. So the second video is a very short one, and it shows you how you can use this built-in viewer. So if you were, a fan of a command line tools, you can use this to take a quick look at the results. So I have the results here in this Gaia result level 1 file, and yeah, you can see the detail. So if you look at the detail, you can see like the prediction, which is the what the answer agent provides, and you can see the aggregate score. So in this case, the agent doesn't perform very well, but I am using the mini models, 4.1 mini model. So we're getting about 0.4 accuracy. Yeah.
Okay, so this is actually good because like one of the things that I think that I'm hearing is that like, hey, this AI stuff, is fun, but can it do real work? This actually tests, yes, it can, or no, it can't. You need to make some adjustments, and you can see inside of what it decided to do, and you can see outside what the score is. Am I getting this right?
Right, exactly.
100% Seth. And I think that also speaks to kind of like how we're thinking about agent framework is not only, hey, helping people build agents, orchestrate them, but then evaluate, observe them, etc. And we want to use, like, we have some great OTelemeters within the framework itself, but also using, Gaia is extremely popular, as Eric mentioned at the beginning. So we want to make sure we're incorporating these external evaluators as well.
All right. So thing number two, so we have the Gaia stuff. That was amazing. Now we have this RL for your, so module 2 inside of the agent framework lab. Tell us about this, Eric.
Right. So RL stands for reinforcement learning. So recently the model has become powerful enough that they have a very strong prior, very good understanding of the world. So that now when you run RL to it, they can learn very effectively. So what's happening in this model model building realm, we want to bring the latest development to where the agents builders are. So this agent lightning module is designed for that purpose. So oftentimes what we found is people who build agents, they have their own stack, they build their own agent using some framework like LangGraph, of course, Microsoft Agent Framework now. And then people who build a model, train model, they bootstrap their own stuff. We want to unify both of them. And Agent Lightning is a Microsoft research project that enables you to run RL on any frameworks that you want. So we work with the Microsoft Research Lab to make sure that the Microsoft Agent Framework is very well supported by Agent Lightning. So this module provides the integration for doing that, as well as a set of samples to show how you can use Agent Lightning to fine-tune your RL using RL to fine-tune your agent. So
when you say RL, because I'm like old school machine learning guy. You're not updating weights. You're updating like context, etc. What is it that you're actually like? What is it reinforced? What is the learning that's happening in the reinforcement?
Right, the learning the effect is updating the weight of the underlying large language model that you use. Yes, so it's actually it's a form. You can think of it as a form of you can think of it a form of fine tuning after you have the model. Yeah.
I see. Okay, good. So this is actual machine learning stuff, because I've heard people like, hey, your agent can learn, and they mean that we are updating the prompt. This is not that. This is actual weight updates inside of them. Okay, so this is okay. And what you've been able to do is like, what is it that it's taking in to do the reinforcement learning, and how is it updating the weights for that? So
yes. So when you run reinforcement learning, there's a couple of important components. So number one is you need to have somebody give a task, right? So the task can come from a benchmark, can come from synthetic data, and so this is coming from the trainer, right? So the trainer on the bottom side, you can see. And then once the trainer, they kind of orchestrate this training loop, and then the trainer give the task to the agent, and the agent will operating on the task, right? But again, we use the OpenTelemetry traces emitted by the agent to send it back to the trainer as the outcome of the training task. So then those traces actually becomes becomes the kind of training data for their next stage of the training. So
how do you ascertain correctness though? Like I'm asking like because you can I'm gonna say a secret that most people don't. Maybe they don't know, but they do. It's easier to mess up a model fine tuning it than it is to make it better. Is right? I mean, that's generally what I've heard.
True. Yeah.
So how does it know that it's the right date? Like, how do you give it the right spans to actually make improvements?
Right. So one of the way you can think about this is RL is different from SFT. So there's a supervised fine tuning. Maybe that is the kind of approach that you tend to mess up the model.
Mhm.
But RL is different. So RL, the way RL works is that the model actually explore different possible way to solve the problem rather than be dictated on a specific way of solving it. So by doing that, the training is much more general. So that model actually adapts to a specific kind of domain without losing much of the previous knowledge of how to do general tasks.
I see.
So yeah, and so this is again also when you do RL, the verification, there is a we call it judge. A judge doesn't necessarily need to be the LM. Oftentimes, because agent are task centric, right? And many tasks have a very concrete verification step where did you onboard the customers, right? Did the code compile? Did you did you if you're playing the game, did you win, right? So there's a lot of these verification that can be done syntactically without going to the model and resulting the RL to find, like, typically there's another tricky thing about RLs is that
Yes.
like you need to know that the model are super smart. They tend to figure out very weird ways to hack your verification. So again, this is not a solution for all those problems, but it gives the developers the tool for them to like tap into these RL algorithms that are like bringing in all the latest greatest improvement to the model so that you can use this tool
I
in
see.
your agents. Yeah.
So I'm okay. So now I think I understand, because you're letting it explore the space. You can actually validate whether it did the right thing or not, like in code. Like, did it complete the task? Yes or no? And if it did, you're like, this is a good example. The thing I had in mind is like you could do evaluative things with other models, but then do you run into this like no free lunch issue with this?
Yeah.
I mean, so that's the thing that was tripping me up. But you're saying no. If you have a task that verifiably it did it correct or not, mechanically you can actually use this to make it better. Is that the sense that I'm getting?
Yeah, 100%. Yeah. So we have seen huge improvements on tasks like that, even with very tiny models. So I have some charts I can show you.
Yeah, let's go to the code first, because I want to see
Oh, yeah, of course.
and then we'll get to the summit. So tell us about this.
Right. So here, what I'm showing you is as a developer, you can use your own agent built with Microsoft Agent Framework without going through some weird researcher code to train your model. So let's say you have an agent defined here. This is a simple agent that with an MCP tool. The MCP is a calculator, and I'm running this agent against a benchmark for performing like math calculation. So you can see there's just one tiny decorator for this Python function at the top called rollout. Once you decorate this function with a rollout decorator, you transforming this function into an RL training function. So with a very simple set of configuration, you can start running your RL training locally on your local GPU, or you can of course run it on a much more powerful GPU if your model is big.
So effectively, this is like your regular agent code with a task, right? And
Right.
an LLM that you would have in agent framework, and you just decorate it with rollout so that your internal RL systems can run this,
Right.
and then it can do the exploration, etc.
Depth, exactly. So the data, of course, we don't provide you with all the data set. We don't provide you with the GPU. This is stuff that you have to bring yourself. But this integration lets you quickly access the latest RL algorithms and apply it to your agent without you going to write a different set of code just for training.
Not only that, but you can like the way this is described, you can pass in a tiny LLM and see how much better it get. Like this is amazing. I'm interested. Like you said, you brought some charts. Why don't you tell us about these charts and tell us if it's actually making things better?
Right. So in this example, like the model is, I can tell you how small it is. It's a 0.5B Quen 2.5 model.
Wow.
And so I think it gets really impressive improvements. I'm only running on a very small portion of the samples of the calc benchmark dataset. So I'm training this model to be good at using the calculator. And I can go from 0.1% accuracy to 0.35 in only 8 steps, 8 epoch of training. So this is going through the 8 times, the basic data set 8 times. And yeah, so this is kind of improvement that you can get. So you just imagine like 0.5 billion parameters, you can run it on your phone, like many of them. So like just try like a little large model and see how well your agent can perform.
And the thing that's cool about this that I'm like starting to like get all excited about is that like if you have agent framework code that you literally can decorate it. There might be some things you need to change, but you can literally like refactor it so it takes the LLM and the task, and you can be like roll out, and I'm gonna go over the weekend, train this thing. And if you have a GPU, obviously it'll be faster, but if it's a tiny model, you could run it on your machine, like your ARM machine.
Right.
That's cool. All right, so go ahead.
Yeah, or you can rent a GPU from a drawer and run it over there.
Oh,
there you go.
I want to go to Disneyland this weekend. So train the biggest model, GPT OSS. Well, okay. So then there's another chart. Tell us about this one.
Right. So this is a much more challenging benchmark. It's not just a simple calculation. So Tau2 is a set of data set that people use to evaluate customer service agents. So you can imagine like you call somebody at a call center, how to help you. So this specifically benchmark runs tests how well the agent performed as a customer service for airlines. Right? You can imagine how hard that is.
Mm-hmm.
I wouldn't want to take that job.
No.
So like it's doing okay. Like you can see the accuracy goes up from 0.3 to 0.4 over the 24 steps, 24 epochs are running over the data set. And yeah, so it's I would say like a very useful way to evaluate, a very common scenarios for your agent. And I think for this run, we use a very small model, which is the Quen 2.5, 1.5 billion parameters. And yeah, so
it's a speedy model. This is amazing. So we learned about 2 things. We learned about obviously the Gaia benchmarks that are in the framework lab, as well as now the RL adapter. Like it's really cool how it's like just builds into that thing. So if people want to contribute, tell us about how they can do that.
Yeah. So I want you guys to join up to contribute. So number 1, so please create your own GitHub repository and go ahead and import Agent Framework Lab and start experimenting, start writing your own code. And so we decided to have a very open community around this. So if you have something that you want to share, submit a PR and we will include it in the list of these projects. And so if something that we think is super valuable, we should take over the maintenance, then we will reach out to you and ask you about it.
That is amazing. Well, Elijah, any final words on all this goodness?
Well, I just think it's awesome in that you're able to get access to these cutting edge technologies, thoughts, processes, etc., and then combine them. As we were talking about RL today, I thought a lot about how you could combine RL and memory and all these other great features that we're kind of building on top of agents to reduce hallucinations and to get them into a more production ready state, and then be able to look at them through eval. So yeah, excited to see what the community contributes, honestly, Seth.
Yeah, I love this. So by the way, if you want to learn about Agent Framework, make sure you go to this link here, aka.ms Agent Framework. So go to that, and then to the Agent Framework Lab, aka.ms Agent Framework Lab. Thank you so much for being with us, my friends.
Thank you, Seth, for having us as always.
Our pleasure.
And thank you so much for watching. We're learning all about Agent Framework Lab, the experimental modules of Microsoft Agent Framework with Eric and my friend Elijah. Thank you so much for watching, and hopefully we'll see you next time. Take care.